So the total charge here on the combination of capacitors is the sum of the charges on the two individual capacitors. Since there's no battery connecting to them to this power supply to add additional charge, and there's no neutralization of charge by combining positive and negative charges. The voltage across each capacitor must be the same after they are connected, and since each capacitor plate is connected to a corresponding plate on the other capacitor by a constant potential connecting a wire. So use the total charge and the fact that equal potential to find the charge on each capacitor and the common potential difference. So the total charge here, Q, we'll call it Q of T, is equal to Q1 initial plus Q2 initial, which is equal to Q1 final plus Q2 final. Okay, well, so Q1 initial plus Q2 initial is equal to capacitance C1 times the potential V1 initial plus C2 times V2 initial. And then the final is C1 times V final, but the final for Q1 final and the final for Q2 final, the potential V is the same. So this is C1 plus C2. We can just pull that potential out front or out back. We're going to multiply it by V sub F. So solving for V sub F, this is equal to C1 times V1 initial plus C2 times V2 initial divided by C1 plus C2. Okay, well, C1 is equal to 2.5 times 10 to the minus 6. And the units here are farads since it's capacitance. This is going to be multiplied by V1, which is 746 volts. Plus C2, which is 6.8 times 10 to the minus 6 farads. Times V2, which is 562 volts. That's V2 initial. Divided by C1 plus C2, which comes out to be 9.3 times 10 to the minus 6 farads. So we find that V final then is equal to 6.11 volts. We can box that in as part of our solution to the question. Okay. We can also then find Q1 final. This would be Q1 final, which is going to be equal to C1 times V final, since V final is the same for Q1 and Q2 final. So plugging in C1 and V final, we find that this is equal to 1.53 times 10 to the minus 3 coulombs. And then the charge on the other one in the final state, so Q2F, is going to be equal to C2 times VF. So plugging in the value for C2 and VF, we find that this is equal to 4.16 times 10 to the minus 3 coulombs. And we can box that part in as our solution to the last part of the question.